Hi all. In this video, I'll explain how a series voltage regulator is used with a controlled transistor. In my previous video, I would have explained about using a series voltage regulator just as an emitter follower by having a pass transistor, series pass transistor along with a Zener diode and a load. But here, and I also mentioned the drawbacks of using that. It had poor regulation and also we didn't had a provision of changing the load also. And to compensate and to improvise the circuit, feedback is also included, which is a negative feedback regulator now, this entire circuit. We have one more transistor Q2 along with the pot, variable potential, variable resistance here. And these are the resistances R3, R4 that is included in the circuit now. The Zener diode along with the R4 resistant forms the reference element or the reference part, and the voltage divider R1 and R2 forms the sample circuit or samples the output voltage and delivers the negative feedback voltage to the base of the Q2. And finally, the feedback Vf is nothing but feedback voltage Vf is nothing but the summation of the VBE2 plus Vz. Same like the previous circuit, we'll assume a case to understand the circuit in a much better way. Now for the case 1 or for a case if my output voltage is increasing, let us check how it is being compensated or it is being controlled. Now when the output voltage increases, obviously resistance R2 increases as a part of the output because this is a part of the output circuit, and this change in R2 causes a change or there will be reflection in the feedback voltage Vf, which means there will be an increase in voltage Vf feedback voltage because uh, this is the voltage across R2, and also feedback voltage Vf is nothing but the voltage of summation of VBE2 plus Vz. Now since Vz is constant, there will be a change in the VBE2 and therefore IB2 changes, and because of this IC2 also changes. There is an increase in this. Now assuming this I3 current flowing through the R3 is constant, to compensate the increase in the IC2, there will be a decrease in the current flowing through the base of the Q1, which is IB1 will decrease now. Now since this IB1 is decreasing, obviously the RCE1 will increase, therefore VCE1 will also increase. This is the because of the increase in the VCE, this causes an offset and therefore V out will decrease now. If there is increase of plus X earlier, now there will be a minus X. So again, it is the original output voltage or the regulated output voltage, which is actually the constant output voltage appears across the load, which is the V out, expected V out. Now, if in case output is decreasing, the reverse scenario happens. Reverse in the sense there will be a change in the R2, again VF changes and VB2 changes, and since VB2 is changed, obviously IB2 and IC2 change, and IB1 increases, and so there will be a change in the VC2, VC1 or nothing but the collector emitter voltage of the Q1 transistor changes, which actually compensates or controls the change in the output voltage. So either it is an increase or decrease, it will be compensated or controlled by this negative feedback setup provided with the Q2. And there is one more simple scenario that we have to understand is our V2 is equal to V2 is actually the summation of VB2 plus Vz, and also it is equivalent to R2 by, it is nothing but the voltage across the R2, right? So like V2 in the sense voltage across R2 is the Vf. So this can also be written as Vf or VR2 is equivalent to VB2 plus Vz, which is also equivalent to R2 by R1 plus R2 into V out, the total output voltage. Fine. So when we equate like this, we can derive an expression for V out, which will be nothing but gain AF, because it is, at last when you try, it is going to be 1 plus R1 by R2 into VBE2 plus VZ. And of course, 1 plus R1 by R2 is actually a gain. So AF into VBE2 plus VZ. So our regulated output voltage will be equivalent to the closed loop gain into the summation of the sensing element, VB2 plus VZ, the reference element. Though it has a proper control, there is a few drawback in the circuit, which is nothing but excessive power dissipation happens. And due to the high power dissipation, output of the power supply is limited to 30 to 40 volts, as a safe value of VC is 50 volts. And most importantly, there is no protection in the circuit, which means there is no sort of over voltage or overload or short circuit sort of protection available in this circuit, for which we have to provide a extra elements, and we have to compensate it. Thank you.